Today, I will be presenting on the adapter design. My name is Abdullahi Amin Nasser, and my student ID is 233924178. As you can see it here. This topic is a key concept in software engineering, and by the end of this presentation, you will understand how the adapter pattern works and why it is important, and also where it is used in real world applications. Let's look at the overview before we dive into the details. Here what we will cover today. Introduction introduction is all about what is adapter pattern and all of that kind of things, the purpose, why do we use it, how it works, explanation of the pattern structure, also code implementations, a practical look at the adapter in action, real world applications where we see it in everyday technology, and lastly the demo, a working example of a working example to solidify our understanding. Let's get started with the introduction. Now let's get started with the basics. What's design pattern? Design pattern is a general reusable solution to common problem in software design instead of solving problems from scratch every time. Developers use design patterns to follow proven solutions that improve code maintainability and scalability. Also, let's look at the adapter pattern overview. The adapter pattern overview, especially the adapter pattern, the definition itself is, as you can see here, the adapter pattern allows objects with in- incompatible interfaces to work together. So the adapter pattern allows objects with incompatible interface to work together. It acts as a bridge between two different systems or components that wouldn't normally be able to communicate. Let me give you an example to understand. Imagine you have a laptop charger from the USA 110 volt, but you are in Europe where the voltage is 220 volt. You need the power adapter to connect your charger to the European socket. Similarly, in software, the adapter pattern converts one interface into another, making different systems compatible. Next, we will discuss why the adapter pattern is important and why we use it, which is which is the purpose, why we use it. Now let's discuss why we use the adapter pattern and how also it works. We use it when developing software. We often need to add a new features or components without modifying the existing system. The adapter pattern allows us to connect new components without changing the old code, ensuring a smooth transition. Also, many organizations, let's go to the how it works. Before we go to how it works, to integrate new components into existing systems without modifying their source code. It is why we use it. To also we use it, as we mentioned it, for to enable legacy systems to interact with modern interfaces. So how it works. The adapter implements the required interface to the client so that the client system can communicate with it. It translates the requests from the client into a format that adaptee or the existing system understands. Let me give you an example of real life. Thinking of language translations or interpreters, if two people speak different languages, an interpreter translates message between them. In software, The adapter does the same job, ensuring seamless communication between incompatible interfaces. Let's go to the actual code and the implementation of adapter pattern, which is here is the mechanism. Let me break down the code for you. The adapter pattern consists of three main components, as you can see it here. Target interface, number one, adaptee class, and adapter class. The last two are totally different, but I will share with you the meanings and what they do. The target interface defines the expected methods for the client, while the adaptee class contains existing functionality but with a different interface. The adapter class is a breaches bridges the gap by converting the target interface's requests into a format understood by the adaptee. So, as you can see here, this is the interface that client interacts with. It defines a play method expecting an audio type or and file name. Also, the adaptee class, which is the advanced media player. This existing class with a different method signature. It has a method play VLC, as you can see it here. Instead of play, the adapter will act as a bridge to translate between them. Let's go to the last to slide number 8. Sorry. UML diagram. UML diagram. The UML diagram on this slide visually represents the adapter design pattern as we break it down, which consists of the target interface, adaptee class, and adapter class, as we mentioned it. Only there is only one another, which is a customer, a client. I mean, the client interacts with the target interface, and through the adapter, can use the adaptive functionality. The adapter modifies the interface of the existing class without modifying its behavior, making it compatible with the expected system. So let's go to the code implementation. Now let's analyze the code provided in this slide. This code demonstrates an adapter pattern using plain different types of audio formats. The key element is in the code. As you can see, the media adapter, which is a class of implements the media player interface. It contains an instance of advanced media player, which is adaptee that can handle advanced audio formats. Inside the constructor, the adapter checks the audio type VLC or MP4 and assigns the appropriate advanced media player. What does this code does? The client calls the media player expecting it to play any format. The media adapter translates the requests and calls advanced media player to handle the specific format. This allows a single interface or media player to work with a multiple incompatible classes. So we will go to the real world applications. Real world applications, for example, electrical adapters or power adapters that allow allow the devices to function in a different countries by converting voltage into plug types. And also in the real world we can use it as a software wrappers. Adapter patterns enable legacy code to interact with modern applications, bridging gaps in incompatibility. For example, if an old system only outputs data in XML, but the new system expects JSON, an adapter class can convert XML to JSON without changing either the system. So As already I mentioned it here, the real world application electrical adapters, which allow the device from the different countries to connect to the lower power outlets, and also software wrappers enable legacy code to interact with new systems without altering the original code base. This is the demo. This one. So let's go to the conclusion. The adapter pattern is essential for integrating incompatible interfaces, promoting code reusability, and also enhancing system flexibility, which is much more important. Thank you guys for watching. Have a good day. Have a good evening.